Lesson 12.3, Inscribed Angles. Remember, a central angle is an angle whose vertex is on the center of a circle. So this would be an example of a central angle. An inscribed angle is an angle whose vertex is on the circle. So an inscribed angle would look something like this. Or maybe something like this. So then our inscribed angle would be from here to here. Another inscribed angle would be from there to there. But our vertex is on the circle. An intercepted arc is an arc with endpoints on the sides of an inscribed angle. So this orange inscribed angle, here is my intercepted arc. On the blue inscribed angle, here is my intercepted arc. Looking at this picture here, I have angle ACB, that is an inscribed angle, and then here is the intercepted arc. So the new words are inscribed angle, which is an angle that has a vertice on the circle, and then an intercepted arc. Here is the inscribed angle theorem. If an angle is inscribed, it is half the measure of its intercepted arc. So here is my inscribed angle. It's going to be half the measure of the intercepted arc. So if the intercepted arc is 70, then the measure of the inscribed angle would be 35. So let's try an example of that. The intercepted arc is 106. We're trying to figure out what is the measure of the inscribed angle. So our rule is that it's half the measure of the arc. So 106 becomes 53 degrees. Let's try a couple practice problems. What is the value of A? So if we focus on just A, here is the inscribed angle that encloses it. So arc A is from here to here. Our relationship is that our inscribed angle is half the measure of the arc, so then the angle would be doubled to get the arc. So 60 would become 120. If I now focus on angle B, which is an inscribed angle, the arc that it intercepts is this one, so I'd have to find the measure of that. We already decided that A was 120, so the measure of the blue arc is 120 plus 30, so the entire blue arc is 150. So then to go into the intercepted arc, we'd have to divide by 2, so half of 150 is 75. Please pause the video and try the second example. Here's the solution. What would the measures of yellow plus pink plus blue arcs be? Right, 360. So, if I take 360 minus 134 minus 128, I get 98 for the measure of arc A degrees. So the value of A is 98. To get the measure of the inscribed angle, then I take half of that, so that angle would be 49. In the next problem, we're trying to find the value of A. A is an inscribed angle, and here is the intercepted arc. Our relationship is that the inscribed angle is half the measure of the arc, so half of 144 is 72. The value of B. I'll highlight the intercepted arc for B, the inscribed angle, and here's the intercepted arc. The relationship is half. So half of 48 is 24. Then C is this angle. Here's what I'm noticing. There's this green triangle in here. We've already figured out that A is 72 and that B is 24. Well, by triangle sum, we can get the measure of this angle, and then the relationship with that angle and C is that they are vertical, so they would be congruent. So doing 180 minus 24 minus 72 gives me 84. Please pause the video and try the next example. So I'm going to look at A first. It looks like A has an intercepted arc that touches this diameter. So that tells me that this intercepted arc is 180, which is going to make angle A a 90-degree angle. B. Well, let's highlight what angle B is. Here's our inscribed angle, and it intercepts arc C. And then I notice this arc 124. So then, what is yellow plus pink plus blue? 360. So then if I subtract 360 minus 180 minus 124, I could get my answer. Or I could remember that blue plus yellow is 180 for a semicircle. So 180 minus 124 is 56. So then to get our inscribed angle, we take half of our intercepted arc for 28 degrees. And then we found value C as 56. Corollaries to Theorem 1211. The first corollary says two inscribed angles that intercept the same arc are congruent. So angle A intercepts the yellow arc. Angle B intercepts the yellow arc. Both of them would have to be half of the yellow. So then by this theorem, or corollary, our shortcut is that they must be the same. Corollary 2, we worked on in the previous example. Because this angle C intercepts a semicircle, it is going to be 90. So on the previous slide, here was us working on that. We had this pink arc that was 180, so then the measure of angle A was 90. Our last corollary says the opposite angles of a quadrilateral inscribed in a circle are supplementary. So angle A plus angle C would be 180. Angle D plus angle B would also be 180. So let's apply those three corollaries. The first thing that I notice is here is angle 1. This inscribed angle intercepts a semicircle, so it's going to be 90 degrees. Then I start noticing some of these measured angles in here. But the only thing I had to find was the measure of angle 1. So I didn't even need to use my 40 and my 70. The second example, we're looking for the measure of angle 2. So here is the inscribed angle. So it looks like I am going to have to use some of those numbers. So the first thing I notice is this 38 degrees is for this inscribed angle. So that's going to pertain to the measure of this arc. So if I double 38, I get 76. And then I notice that this green angle 2 also touches this intercepted arc, so it's going to be congruent to 38. the last example is going to use the fact that opposite angles of a quadrilateral inscribed in a circle are supplementary. So then we know that 1 plus 3 is 180, 4 plus 2 is 180. But let's mark some of these. So angle 1 is from here to here. So notice that it marks an intercepted arc that is a semicircle. So then I would say that angle 1 is 90. Angle 3 does the same thing. So I'm going to label that one 90 as well. So the measure of angle 1 equals the measure of angle 3 equals 90 degrees. Now I'm going to get this dotted line involved, which is the diameter. So it looks like this angle hits the arc 60, so this would be 30. And if I did this angle, it hits 80. So I'm going to call this one 40. So then angle 4 equals 70. And then because we have a quadrilateral, we knew that the measure of angle 4 plus the measure of angle 2 equals 180. That was our corollary. So then by substitution, 4 is 70. So what is the measure of angle 2? 110. Here's our last new theorem for today. Theorem 1212. The measure of an angle formed by a tangent and a chord is half the measure of the intercepted arc. So the orange is my tangent and the red is my chord. So here is that intercepted arc. The measure of this angle is half of the yellow. So again, here is my chord, here is my tangent, here is the arc. This angle is going to be half of the yellow. So let's try one of these. In the diagram, SR is tangent to the circle. If the measure of arc PMQ is 212, what is the measure of angle PQR? So here's the information. The yellow arc is 212, and the orange angle is what we're looking for. So I'm thinking we're going to need this pink arc so that we can start. Yellow plus pink should be 360. So the pink is 148. Then this orange angle is going to be half of 148, so we get 74. The other way to do this one would be to half the 212, so that would give us this angle, and we get 106, and then the linear pair to 106 would be 74. You'd have a couple choices on that one. In the diagram at the right, segment KJ is tangent to circle O. What are the values of X and Y? The first thing that I notice is that here is an inscribed angle. That angle intercepts this arc. That pink arc would be double 35. So I'm going to write 70 in there. Then it says that KJ is the tangent. And then here's the other part of that angle. So from the previous slide, here's the rule that we're looking at. So this is the angle we're looking for, so we're going to half the 70, so X is equal to 35 degrees. Then we need to focus on angle Y. So it looks like angle Y goes from here to here. So that's an inscribed angle. So we're concerned about this arc. So I need to figure out what that arc is. Then I notice that Q to L is a diameter, so then yellow plus pink should be 180. So 70 plus 110 is 180. So then half of 110 would be 55. So y is equal to 55. Please go to the last slide for section 12.3 and try these problems. Pause the video until you're ready for answers.